Wouldn't that be a better thing to look at? Okay. So what is the formula for water again? H2O. So we need what? We need 1 oxygen for every 2 hydrogens, right? So how many waters will I actually be able to make? Okay, 3. And then we would go like this.
You think that would have worked for this double bond? I mean, that's not
Okay, so there we go. So those are 3 waters. Now that takes care of those. It takes care of that one, that one, that one. What remains?
a lot of oxygen.
Yeah, a lot of oxygen remains, doesn't it? And in fact, I'm going to argue that can we just have lone oxygen atoms flying around? No, I'm going to argue, in fact, that we don't even get to make this one, right? Because it involves leaving a lone oxygen hanging around. So I'm going to say that we actually are going to have 3 oxygen molecules left, and what else? Yeah, 2 hydrogen atoms, right? Which is 1 molecule. Does that make sense? In other words, according to the hydrogen, how many water atoms should I be able to make? Yeah. According to the oxygen, how many water atoms should I be able to make if I had all the hydrogen I needed? 1, 2, 3, 4, 5, 6, 7, 8. If I had all the hydrogen I needed. Does that make sense? Like if I had tons of hydrogen. So in theory, I could make as many as 8 water here. I could make as much as 3 water here. How much water do I actually get to make? Just 2. Just 2, arguably 3. We could say if we left that oxygen, if we assume that oxygen can go off and find something else to do, we get 2 or 3 waters. In other words, if you had these differently, if you said that, yeah, we do get that 3rd water, and then we have 1 oxygen that just has to go off and find a friend somewhere, that argument could work too. As long as there are other things around, that could happen. But the point being, do we get 8 waters? Even though I have enough oxygen to get to 8 waters? Why not? We don't have enough hydrogen. In other words, the hydrogen did what? The hydrogen? Yeah, very good. That's much more sciencey than I was going to say. I was going to say it ran out. But yeah, no, but that's good. I mean, that's a better answer. The hydrogen determined how much water we could make because we had, stoichiometrically speaking, less of it. Right? Does that make sense? We didn't have as much hydrogen as we needed to use up all the oxygen. So notice that oxygen is left over because all of the hydrogen has been used. So when a reaction occurs in the real world, there's not always a perfect ratio of reactants present. In other words, a perfect ratio would be ensuring that we have twice as much hydrogen as oxygen exactly, right? So if I had 4 oxygen molecules, I would want to have 8 hydrogen molecules, right? That would be a perfect ratio. Because H2O, there's twice as much hydrogen as oxygen. Does that make sense? But in the real world, that doesn't always happen. In fact, a reaction will always stop occurring when we run out of an ingredient. And it makes sense. Let's say that I ran a factory that makes cars. Just assembly. You know, this is how car manufacturing works. They don't build the whole car in one plant. They ship in all the parts. You know, the engine's put together in an engine factory, an engine assembly plant. All the different parts are built elsewhere. And then you have assembly plants where their only job is to take all these parts and put them together and make a car. Does that make sense? Okay. So if I'm making Tesla S models, and I've got all thousands of batteries piled up and thousands of windshields piled up and thousands of axles and thousands of motors, but I've got 8 wheels. How many cars am I making? 2. That's it. Does it matter that I have thousands of windshields? No. In fact, if I had 7 windshields, how many cars am I making? Who gets the car missing a wheel? Who's that poor sucker?
You said windshields.
Oh, did I say windshields?
You did.
Oh, failure, Orlando, and it's on tape. Just like every other day. Anyway, yeah, so sorry, if we had 7 wheels, how many cars am I going to get to make? Just one. Just one.
Yeah, 3 wheels.
That's true. And let's face it, that'd be pretty cool. Driving the world's only 3-wheeled Tesla, but you'd have to retool your entire plant. So let's go ahead and assume we're going to get 1 car. In other words, when we run out of one thing, production stops. And that thing we run out of, we call the limiting reagent. And this is a case where we introduce a British word, reagent. What do we normally call the things on the left side of a reaction? Reactants. Okay. Another acceptable term for that, and the term the British use, is reagent. Yeah. So when we say limiting reagent, it just means the reactant that we run out of. Limiting makes sense, right? It limits how much you can produce. So the limiting reagent is just the reactant that runs out first. Okay, I want to do one more simple just atomic level example, and then we're going to jump right into stoichiometry and start talking about masses. But I want to do one more simple one. If I have 3 carbon atoms and 4 hydrogen molecules, how many methane molecules can I make, which is CH4? And of course, that 4 should be a subscript. Shame on me. So if I have, well, be careful. Draw it out. 3 carbon atoms. How many hydrogens do I have again? 4 of them, okay. Does that make sense? Any questions about that?
Where's your 1 hydrogen level?
So interestingly, the one on the left with them at equal angles is what we would expect it to look like, and the one on the right is actually what it looks like. When something makes 4 bonds under normal conditions, they arrange themselves at the biggest possible angle between them. And the biggest possible angle between 4 spokes coming out of one hub is, you're not gonna know this. There might be like one kid who's like right ahead. This is, we take this in the grade 12. You'd think it'd be 90 degrees, right?
Yeah.
But in fact, when you have 4 spokes coming out of a hub, you can get them to be 109.5 degrees away from each other. So each carbon atom there forms an angle with, or the hydrogen atom rather, forms an angle with the other of 109.5 degrees, and it makes a shape called a tetrahedron, which is basically like a pyramid base with one thing sticking straight up. A tetrahedral arrangement. You don't have to worry about that. The first one I drew thinking I'd be simplistic, then I forgot about that and drew the next one the way it actually looks. It does not matter. But does that answer your question?
Yeah. I just assumed you were not.
That's right. It's a 3D shape. In 2 dimensions, the biggest possible angle would be 90 degrees, and you'd make a cross.
Oh, that makes more sense.
But in 3 dimensions, you can get an angle of 109.5 degrees maximal between them. That's right. Yeah. And if you actually look at the model kits, you know, the ones that I brought for this lesson that are right in front of you right now, you'll see that that's the angle they're kept at. They don't make 90-degree angles. They make 109.5-degree angles. Anyway, more on that on at a later date. Okay. Now we're going to jump right into it. We're going to do a tough question. It is. It's a tough question. But we're good. We're going to do a single displacement reaction. What's a single displacement reaction again? Okay, good. How do we know if one happens, by the way? So what's up? Yeah, what do we call that reaction chart? You built one. Activity series, good. Okay. So here we go. We have 3.2 grams of magnesium metal. Now, if this were like other questions that I'd given you, I'd just say, and excess copper chloride, right? All the questions we've done in stoichiometry so far, I just said, here's how much of the one thing you have, and then don't worry about the other one. You've got plenty, right? This time I'm not saying that. This time I'm saying you have 3.2 grams of magnesium metal, and then in a beaker, there's 5.3 grams of copper chloride. Now, that copper chloride's been dissolved in water, but there's 5.3 grams of it. Oh, for God's sake. Sorry. I meant to mute my phone. If anyone's curious, I have 2 new voicemails. I'm not curious. Okay. There we go. Sorry about that. So, what's the first thing we need before we can do any stoichiometry? A balanced chemical equation. Okay. How do I start that? Yeah. Okay, so Mg, because that is magnesium metal, right? Now, copper 1 chloride, I'm going to have to figure out the formula for that, aren't I? What charge does copper take in this case? How'd you know that? Sorry? Very good. So in this name, the fact that it's called copper 1 means copper takes charge 1. And chlorine takes what charge? Very good. So what will the formula of this thing be? CuCl. Very good. Questions about that? All right. So magnesium plus copper chloride, and it's dissolved in water. How am I going to say that? Aqueous. Okay. Now, if you want to check your activity series, you can, but I'm going to tell you I picked one that works. So this reaction does happen. So what am I going to have on the right side of this equation? What am I going to have on the right side of this equation? What happens? Single displacement reaction. Yeah. Okay, so what will be by itself now then? Okay, and how do I indicate that that's now on its own? Yeah, it's solid copper. Good. And? Good. So I've got to do a little side page calculation for magnesium and chloride. So what charge does magnesium take? 2+, and chlorine takes what charge again? Okay, so how will this work if they can't charge balance? Yep. Very good. 1 Mg gives us a charge of 2+, and it takes 2 chlorines to give us a charge of 2-. So MgCl2. Hopefully that feels comfortable and familiar to everyone. Done lots of those, yeah. Don't be shy if it doesn't. I can explain it. Okay, and I am done. I think I am. Pretty confident I'm done. I've got all the stuff on there. Oh, no, you're right. You're right. Okay. Now I'm done.
Can I just start agreeing with you?
You have 2
Yeah, let's
chlorine
start
on the right, but you don't have 2 chlorine on the left. So you have to put a 2 in front of the CuCl.
Like that.
Yes, and then a 2 in front of the Cu.
Okay, like that.
Now it's.
Now I'm done?
Yes.
Okay. In answer to your question, no, I'll just be more obnoxious about it. Yes, I'm sorry. There you go. We're on page 2. You can catch up with page 1 after. Okay. Does anyone have any questions about how we got our balanced chemical equation? Okay. Now, there's a lot of different ways to teach this. All right? A lot of different ways to teach it. Here's how I teach it. I say, let's just imagine that we've been given 2 questions here. And the 2 questions are, how much copper could I make if I had 3.2 grams of magnesium metal? That would be question 1. The second question would be, how much copper could I make if I had what?
3.2 grams of magnesium.
Yeah, so that's one thing I can check. I can say, okay, if I have 3.2 grams of magnesium metal, how much copper metal can I get at the end? What else could I ask, given this question?
You have the
How much, okay, how much copper do you have? How much, if you have whatever that ended out of copper is, how much magnesium can you get? Or, no.
You could do that. Stoichiometry will let you do that. But I want you to look at this question. What else have I given you in this question? I've told you there's 3.2 grams of magnesium. So we can ask what would happen if we use all the magnesium. What else have I told you? Yeah, what's that? 5.3 grams of copper chloride. Good, very good. So the other question we can ask is, what if we used up all of the copper chloride? Now, if they are perfectly matched, what should those 2 answers be the same? If I had worked this question out, so I use exactly the right ratio of magnesium to copper chloride, they should give me the same answer. Does that make sense? But if one of them runs out, they'll give me 2 different answers. Does that make sense? Go back to the first page for a moment. I want to look at this question. If all I knew about was how much carbon I had, like this, how many methanes could I make from that? If I use all my carbon, how much methane can I make? 3 methanes. Good. Now, let's ignore that. If I use all of my hydrogen, how much methane could I make? 2. So how much methane did I actually make? 2. Why?
That's the hydrogen limited your amount of methane.
That's right. If I have enough hydrogen to make 2 methanes and enough carbon to make 3 methanes, when do I have to stop? At 2. Does that make sense? It's like saying if I have 4 steering wheels and 4 tires, how many cars do I get to make?
1.
Just 1. Even though I have enough steering wheels for 4 cars, if I only have enough tires to make 1, I'm only making 1. Does that make sense? So what we're going to do here on this next page is the same thing we just did there, only it's a little more complicated. But we're going to say, okay, how much copper can I make with 3.2 grams of magnesium? We'll work it out. We'll get an answer. Then we'll say, okay, how much copper can I make if I start with 5.3 grams of copper chloride? And we'll work it out, and we'll get an answer. We're going to have 2 answers. And once we have 2 answers, which one's going to be the right answer? Yeah, which one?
The lowest.
The lowest one. Excellent. Very good. Just like with the cars. If I have enough windshields to make 5 cars, and I have enough drivetrains to make 7 cars, but I only have enough seats to make 1 car, how many cars do I make?
1.
1. The lowest number always wins. Makes sense, right? Once you've run out of something, you're done. So we're going to have to do stoichiometry not once for this question, but twice, which makes sense because stoichiometry always starts with just one given number, right? Right? We always take that first given number and then keep going. Well, here, how many given numbers have I given you? 2. So we're going to have to do stoichiometry with both of them. And then once we've done that, we're going to take the lower number. So let's try this. How about we do the first one together and you do the second one by yourselves? Is that fair?
Yeah.
So which given do you want to start with? Doesn't really matter which. The copper chloride? Okay, let's do that one first. Now, what is my answer going to be? What is the question asking me to find?
How many grams of solid copper will be produced as a result of the reaction?
Okay, so our answer is grams a mass or a number of moles or a number of particles? What is it? Mass. So the symbol I'm going to use for what I'm looking for is lowercase m, and we're talking about solid copper, right? So the first thing we're going to do, actually I should work in blue, black looks like the question, is start with my given information. What is my given information here? 5.3 grams of CuCl. Okay. Now, for all stoichiometry, what's the first thing I want to do? Eventually, I want my answer. When I get my answer, it's going to be in grams of copper, right? Grams of something different. Yep.
You're going to want to cancel the grams of copper chloride.
Okay, so I want to cancel the grams of copper chloride. And what do I want instead at this first step?
Grams of copper?
Great. Can I go directly from grams of one thing to grams of another? No. What unit do I have to be working in if I'm going to go from one compound to another? Moles. So I'm going to need to go from grams of copper chloride to moles of copper chloride. Because again, can I go directly from grams of copper chloride to moles of copper? No. You can only go from grams to moles of the same unit. Now we're going to have to come back and put numbers in here. Let's do it now. How do I know how many grams make up a mole of copper chloride? Where do we look? The molar mass, which I find on the periodic table. Good. So let's do that for a second. Let's do a little bit of math here. And what should the molar mass? Whoa. What should the molar mass be? Take a minute and figure it out. Yes, ma'am. Do you have the number?
No.
Yeah, of course. Yeah. Of course. Of course. Do you guys see that you have won a battle? I've stopped saying you don't need to ask. I've just given up and accepted that you all do ask. Not if somebody said don't ask. Anyway.
Okay, the water bottle one I can see asking, but the lunch one would kind of be like,
Yeah.
maybe don't ask and just go.
Yeah. I trust your manners. Right until I don't.
98.9991.
What'd you get?
98.999.
9991. Great. Did anyone get the same or different? How did you get that, by the way? I'm going to stop showing it. I'm going to start trusting you guys. But how did you get that?
You have the mass of copper chloride.
Very good. Right from the periodic table. So again, I don't want to go with just one person. Not that I don't trust you, Kendrick, because I totally do. But just, did anyone else get the same? Please actually do the math.
You still have that thing. You still have.
Same thing.
Okay. So, oh, I want blue. What? What's God got to do with this?
Oh, no.
I mean, I think the God probably has a lot. What?
Say it out loud, Mr. Orlando.
What? There's 98.9991 moles of copper chloride and 1 gram of copper
No,
chloride.
there's not.
Okay, so that's obviously absurd. So what should I be writing?
1 mole.
1 mole of copper chloride. So here's the deal. Because our given is actually only 2 decimal places, yes, you totally could round it. But I'm going to keep them all here just for the sake of completeness, but you would get the exact same answer if you rounded it to a couple decimal places. But I'm going to leave it be. Okay, if I stopped calculating now, what would I know? I'd know how many moles of copper chloride I had. Somebody tell me what my next step should be. Yes, ma'am.
Moles of CaCl and moles of copper.
Great, and where are those going to go? Like what's on the top, what's on the bottom?
Moles of copper should be on top.
Okay, I want moles of copper, and so I want moles of CuCl to cancel, so I'm going to put it down there. Great, and where am I going to get numbers for that? Great, my balanced equation. And what are those numbers here? So it's 2 and 2. So in the chemical equation, 2 moles of copper are used, and 2 moles of copper chloride are produced. If you said 1 to 1, it will work. I prefer to write it out like this, but you're not wrong. Okay, if I stopped calculating now, what would I know? Yeah, I'd know how many moles of copper I have. Was that the question as it was asked? No. So the final step is to do what? Convert to grams, which I do by canceling moles, right? And putting grams. And then, what? There's 2 moles of copper in this reaction, and the molar mass of copper is 63.5463. Is that good? Why not? Good. When I look at the periodic table, does it tell me how much 2 moles of copper weigh? No. The periodic table tells me how much 1 mole of something weighs. So when we do grams to moles, it's always how many moles? 1. Always, 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 always. When we go grams to mole, we're talking about how many grams are in 1 mole. And again, that is the most common mistake that students make. And again, it's a good mistake. It's a mistake that shows you a mistake that shows you, and so it took me a moment to process that. I couldn't even react instantly. It was like, that took a moment. What cancels now? Moles of copper will cancel, and when I'm done this calculation, what will I know? Very good. So I want you to go ahead and calculate that and tell me the number. And keep in mind, how many significant digits do we have here?
2.
We have 2 sig figs. Good. Is everyone comfortable if I just, anything I don't point to is infinite?
Yeah.
We can end that charade.
You could just do it once you got the lowest one, you stop.
Okay, so it's agreed then, 1 sig fig. You had to do it. No, that's okay. That's okay, snarky. That's okay. You had to go there, and so okay. Yeah. You want to listen. You want to be snarky. 2 can play that game. Okay, has anyone done this math? What do we get?
3.4.
What do we get?
3.4.
Okay. In other words, I want somebody to say this equation as a single sentence. Just give it to me. What is all this math told me?
So this tells you that the mass of copper equals 3.4 grams.
Sure. That's good. Even more, what I'm going to say is this. What I learned from this set of equations is very specifically, if all the copper chloride is used up, we get 3.4 grams of copper. But what assumption does this rest on?
We have enough.
Very good. So this assumes that we have all the magnesium we need. So what am I going to do next? I'm going to do, you could do this a bunch of different ways, but my suggestion is this. Now we do a second calculation, and this time, instead of assuming we use up all of the copper chloride, we're going to assume that we use up all of the magnesium and see how much copper we get. So try and do the same thing. This time, assume we use all of the magnesium. Sorry? No, what was I given in the question? Yeah, I was given 3.2 grams of magnesium. So we're going to use that. So I want, again, we're still going to be finding the mass of copper. We're still going to say, what is the mass of copper I get? But this time when I start with 3.2 grams of magnesium metal. You will get to the point, by the way, guys, where you get a question like this and you'll be out in a minute and a half. It's like boom, 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 number, boom, 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 number, low scale. Yeah. Yeah. Sipping on your coffee. Okay. No, what we're finding is the mass of copper. So our answer is going to be how many grams of copper. That's what I mean. Just like up here, the whole calculation we're doing is to figure out how much mass of copper. By the way, that stressing you out, don't write till the end. You know what I mean? Like what I'm saying is at the end, I put it at the beginning so I remind myself where I'm going.
No. So like we're trying to find out the amount. But did we with magnesium?
So did I get the number wrong? I get the number wrong sometimes.
No. Doesn't it just figure out?
Yeah, so we have to do it again. We have to do it again. We have to do the whole question again, but this time instead of starting with the copper chloride, we're starting with the magnesium. Think of it this way. Go back to the previous page. To answer this question, I have to answer it twice. I have to say, how much methane can I make using the carbon? I can make 3. Then I have to look at it again and say, how much methane can I make using the hydrogen? And the answer is 2.
Yeah, but then we just figure out.
And isn't it 2 points together than copper?
Yep. I don't think so.
Oh, but I'm just reading it wrong.
I think I'm good.
No, I'm
Just
wrong.
figured out copper.
Yep. Now you've got to figure it out again.
With magnesium.
So what we're asking is this. Look at me. It's like the car question. We say, how many cars could I make with 3 steering? Okay. Then again, we say, how many cars could I make? Same question. With 4 wheels. 1. So we ask the same question twice. How many cars could I make? That or the only thing that changes with all. So here we're saying, how much copper could I make with CuCl?
All right, we're right now.
Big catch, we got. Does that make sense?
Yeah, I thought you had to figure out copper and then figure out.
We all have the same answers. Yeah, we sleep today.
It's like
Oh, and broke.
It's actually here on It's correct.
Yeah,
Wait, so that does that mean?
We did this. Why don't you try doing it?
No, is that
Yeah, try doing it.
not happening?
Can I be nosy?
No, I don't like that.
What?
I don't know what I was
I like this.
doing.
The only thing I don't like.
know what they
Okay.
do here.
Okay, so now we go back to the chemical equation and we want to get to copper, right? So we want to stop talking about magnesium and start
Oh.
talking about copper. Okay, so let's look. We want to go from moles of, so grams of magnesium cancels. If I stopped here, I'd know how many
Moles?
of
Magnesium.
I had. Good. Now I want to get rid of moles of magnesium
Okay, so
and I want to talk about
moles of copper.
good. Now I have to make these numbers true. So let's look at the equation. In the equation, how many moles of magnesium do we use?
Okay. Just one.
Good. And how many moles of copper do we get?
That's where you get it from. Okay, so 2.
Very good.
That makes sense now. Okay.
There we go. And then,
And then,
so now if I stopped here, I'd know how many moles of copper I end up with. But we say 1 mole of copper weighs that many grams. And now I'll know how many grams of copper. Good job.
oh,
Listen,
okay, so I was
again,
close.
you're 90% of the way there. You did all the hard stuff. And then, surprise, surprise, bailed on the easy stuff. That's okay. That's a good place to be. Yes, ma'am.
Since there's only 2, would it be 16 or would it be 16.7?
16.7 rounds to, yeah.
What, okay, first, if that's right.
Yeah, it looks great. So if you stop now, you would know
Moles.
of.
Magnesium?
Good. Now, do we want to talk about magnesium?
No,
We want to talk about,
copper.
so I want to cancel,
So you want to cancel moles of magnesium, so that goes on the
yeah,
bottom.
and I
Okay.
want,
Moles of copper.
you got it. You're doing great.
Finishing sentence, what I say, when magnesium is added, we get 7.
So if we use all of the copper chloride, we get how much? 3.4. If we use all of the copper, what would we get? Okay, now which one of these is actually going to happen? If I put these two things together, am I actually going to get 17 or am I actually going to get 3.4? Right. So this is the real answer to the question. But also, which one of these ran out then first? The copper chloride or the magnesium? Magnesium would have kept going. Copper chloride runs out here. Does that make sense? So the real amount of copper we get is 3.4 grams. And the reason is copper chloride is what we call the reagent, limiting reagent.
Did we learn that today?
Yeah. Oh, you weren't here.
Yeah.
Right. Okay, so the name we have for the thing that runs out is the limiting reagent. Yes, you have a hand up.
Yeah, I'm kind of confused.
Great, let's take a look. So you said we start with 3.2 grams of magnesium, and because it's 24.3051 grams of magnesium in a mole, if we stopped calculating now, we would know how many moles of. Great. Well, we don't want to talk about magnesium. We want to talk about moles of copper. Good. So we put moles of copper here. What do we have to cancel? Good. And now where am I going to get numbers? Yeah, good.
Oh, so it'd be like 2 to 1.
Yeah.
Is that it?
Very good.
And then we have to cancel out.
Mr. Len, is that
Moles,
okay?
because we
Yeah.
want.
Oh wait, that just got canceled though. Oh, let me go grams to moles.
That's right. Very good. Perfect.
And I'm just gonna have to get out.
Yeah, you bet.
I give up. Sorry.
You may want to watch the lesson too, because it is tricky stuff. Once you get it, it's like anything. It's like anything else. The nice thing with the chem stuff is once it clicks, you'll find them all easy.
Like at Dame last year, we
Yeah.
learned all of the displacement.
Yeah.
And like everything in like competition.
Yeah. Yeah. If they teach you pretty hardcore in the 10, it helps you a lot when you get to the 11, for sure. Okay. So yes. Can we go through this? All right. Ask what would happen. Oh, that was pretty. What would happen if we used up all of our magnesium? Okay. If I have 3.2 grams of magnesium, what's the first thing I want to do? What do we think? What's the first thing we want to do here?
Find out how many moles there is.
Very good. So we want to figure out how many moles of what? Good. And what do I need to put on the bottom of this? Okay. Now I need to put numbers in here. Where am I going to get those? Sure. For this one, I'm going to get the number from. Like, what numbers go in here? Talk to me. 1 mole. Okay. And how much does 1 mole of magnesium weigh? Okay, great. Does everyone agree with that? If I were to stop calculating now, what happens? What cancels? What do I know? Of magnesium, because grams of magnesium would cancel. Does that make sense? So if I stopped calculating now, I'd know how many moles of magnesium I'm starting with. Of course, that's not what I want to know. So what do I have to do next? Next step. Yeah. So I want to know how many moles of copper will get made. And on the bottom, I want to cancel moles of magnesium. Now, where am I going to get these numbers? Is that the same? Is that the same as you have? Oh, okay. No, don't be sorry. I just thought I saw you react. So I was wondering if I made a mistake. I do that. The equation. In the equation, how many moles of magnesium do we use? Just 1. So I'm going to put 1 mole of magnesium. In the equation, how many moles of copper get produced? 2. So I'm going to put that there. Does anyone have any question of that? Once we figure out how many moles of magnesium we have, we know that for every mole of magnesium we use, we make 2 moles of copper. If I stopped calculating now, what would I know? Yeah, I'd know how many moles of copper get made. Is that the question? No, the question is how many grams of copper. So yes, what's my next step? So I want to know how many grams of copper. Moles of copper goes on the bottom. Good. And moles of copper will cancel, leaving me with grams. I just see a number here. What's my number? 17? That's the answer. I like that. But what numbers go in here to give me that answer? 63 point. Okay, and that is how many moles? 1. Always 1, right? That's what the periodic table tells us. That was a very quick one. I was like, don't mess with me, Orlando. Don't put a stupid number. Just say 1. Okay. And we get the answer 17. Okay. Now, this means that if I do what, I get what? Give me this as a sentence. Yeah, and if we react all of that, right? Yep. So if we use all the magnesium. Sorry, I interrupted. Okay. Here we go. We have 2 possibilities. If we use all the copper chloride, we get how much copper? 3.4 grams. If we use all the magnesium, how much copper do we get? Okay. Hey, if I use all the windshields, I get 3 cars. If I use all the wheels, I get 17 cars. How many cars can I make? 3. In this case. So here, if I use all the copper chloride, 4 grams. Does it matter that I have 17 grams of copper worth of magnesium to use?
No.
No, because I'm going to run out of what? Good. So the most appropriate answer must be then, we will get 3.4 grams of copper with magnesium metal left over. By the way, it would be a whole separate question to figure out how much magnesium is left over. I'm not going to ask you that now, but I might later. What was the limiting reagent? Copper chloride. Good. Was it copper 1 or copper 2? Copper 1 chloride was the limiting reagent. Good job. I want you to try the next page, next question. The only way to get good at these, listen to me, look at me. I want everyone, if there's 11 people in this room right now, I want 22 beady eyes looking right at me. So no winking either. The only way to get good at this is to just keep doing them until they're easy. There's just no other way. There's nothing I can do. I would love to have some magic teacher wand I could wave and say, I explained it so well, you can now do these. It doesn't exist any more than a volleyball coach can wave his magic volleyball coaching wand and all of a sudden you can jump serve perfectly every time. It doesn't work that way. Doesn't matter how good the coach is. Doesn't matter how clearly he explains the mechanics of a jump serve. The only way you learn to nail that in the exact spot you want every time is to just do it a million times. Does that make sense? The nice thing is this is a lot easier than learning to jump serve. You don't have to do it a million times, but you probably do have to do it 20 times, maybe 30 times. So if you think, I kind of get it, I've done one question, you're going to forget it. I promise. I promise you will forget it. It will not stick with you. It couldn't possibly stick with you. All right? Any more than the first time you luckily happened to land a jump serve that was perfect and looked great, you said, well, I got that skill down. I'm ready just to wait till the game. You're not going to be able to do it. It doesn't work. Okay, so it doesn't matter. It does not matter if it feels clear or feels confusing now. Every one of you needs to do at least a dozen more examples before you really have this. The great thing is, once you can do these, the simple stoichiometry questions are just like, they're nothing. You'll get to them and be like, well, that's a joke, and just move on.
Is there longer questions?
The only thing I could do to make it longer would be to say how much magnesium is left over, right? If this is the limiting reagent, how much of the reactants remain? Not in this course. This will be as long as they get in this course. Now, I took some upper level chemistry courses where they get substantially longer than that. I mean, I guess I take that back. I could have given you a mass in kilograms, and then you'd have a first step where you had to convert from kilograms to grams. So that'd be one more step. In fact, I'll tell you right now, you're gonna see that. But outside of that, like outside of a simple unit conversion, no. This is as long as this course gets. Me? Oh God, in physics, probably like pretty substantial. Yeah. Because then you can get to addition and subtraction of them too, right? Where you have to start adding and subtracting, it gets a bit more complex. But listen, I mean, I'm not gonna lie to you. Like in terms of physical chemistry, it gets a little bit more complicated for you if you take it, which is a great course. And then like I did a little bit more complicated than that once you get to university. But like in terms of physical chemistry, this is pretty complicated stuff. You guys are doing challenging stuff. And then organic chemistry comes and it just makes all this seem so easy and lovely. You pine for this and you wish it were like this. So I want you to try the next page. Oh, what is with me and subscripts and superscripts today? Yep. Yeah, you bet. And then you'll see the last page of this is just pages and pages of practice. You just need to do pages and pages of practice. There you go, man.
This is all recorded then?
Yes, yeah, it'll be online.
Ew, so I'm gonna hear my voice saying this.
Yes. Isn't that very
Hello,
you could
future
do?
Kira.
You could very carefully plan a conversation with yourself, or you could like write down what you said, keep a transcript, and be like, "Hi, Kira, how are you?" And then when you watch it, you can be like, "Hi, I'm good." And then you go like, "I'm glad to hear that. How was your grad photo?" And then you can say on like the video, like, "It was pretty good. I'm happy with it." And you can hold like a whole conversation.
That is when
That's
you,
what I would do.
that is when you have no life.
First of all,
I feel like you do that if, like, you're home alone and like you feel like
You like
need
rewatch
something
out
to
of your
talk to.
lessons.
I have never.
He's
I
done
know,
that.
Listen, not only have I never rewatched a lesson I've taught outside of being forced to, and like when I was in teachers college, they filmed you and you had to watch yourself teach, which is just the cringiest thing. Yeah, the most cringe-inducing thing you can possibly imagine. When I die and go to hell, and let's face it, just a question of when, it will just be like a repeated loop of these lessons for me to watch. I'll be like, oh,
Well, same for all of us.
oh no, oh, there it is. Oh, it's too great.
Michelina, you have done stuff like that before. You've recorded a lesson and then talked to students when you're recording it in your basement.
Yeah, no, that's true. Because it's funny every time. If you're going to be away, so you record a lesson, but then you're like, hold on, stop talking to you. And you're like, Kira, put your hand down. I know you didn't even know the answer, but you gotta let everyone answer. It's fine. It's fine.
I think one of them was just like, okay, Caitlin, so what's the answer? Come on, I'm waiting. Just yell it out. I think that was one of them.
I once
Oh,
had something
yeah.
who pretended to be absent, and I actually just taught the lesson from the science office. So I called that one as well. You. That's just fun.
Are you able to come over on Saturday? I don't know yet. Let me get this down, okay?
I realized that I was creative.
That's
So
too ideal.
you don't have to worry about school.
Mr. Linda,
Yeah.
how did none of them ever catch you? That's my
I
biggest
might be
question.
able to. I
What-
don't know
yeah,
because
right,
I
talked to
forgot
them
about
before.
the fact that
So
Kayla comes back this week and wanted to have her
I just
girls'
asked a
day
friend of mine
on
to pretend he
Friday.
was subbing just for a minute. Go ahead and set
I mean,
him up
not
and
that
get
we
him
couldn't do
started.
that and then have a sleepover at your house, but
Oh, nuts.
wait, all of this is me on this video. Yeah, we'll talk about this next period.
Get to work.
I need help. I'm typing and uptype and stuff. And thirsty.
Did you make this lesson before you use that?
I need my cat. That's fine.
So what, did I do this when I was in grade 4?
Move notification. Cat.
Well, obviously, you know, no, I didn't. You didn't bother.
This is what everyone that watches this video is gonna hear at this point. And they're gonna be like, why?
It's on lined paper.
Wait.
You could be
I
taking
think it's
notes the
even
way I
worse.
took notes
Let's
when I
put
was
on a
in high
video
school.
from
I could
that.
drag out the overhead projector
No, Andrea, just no.
with the turning wheel on it that moves like the.
The formatting, you even said that one on report that had no formatting. They just-
No, that's true. Listen, you want to
He's
just
just like,
totally just
no.
go nuts. You will then not have a
Andrea,
note.
I'm
But,
really trying to
like,
get this
I
done.
would totally respect you if you throw it out because the formatting is bad.
Okay.
I totally get that.
About copy mine. So that you don't have to worry about talking to yourself.
No, Alondra.
I do that. Yes, I was-
Wow.
Oh wait, it's coming up.
This one, and then which one is the insoluble?
Is it what?
Which one's the insoluble of the?
Soluble.
Oh, I don't know. What did I get?
It has to be one of them.
Calcium carbonate. Calcium carbonate's a solid. Yeah, I'll save you guys time looking up the solubility table. Calcium carbonate will be a solid. It doesn't dissolve nicely. Do you know what calcium carbonate is? Yeah, it's limestone, but it's also just chalk. So have you ever seen like the famous White Cliffs of Dover? Beautiful, beautiful, famous cliffside in Dover, England, which faces across to, what's the place? Calais in France, right along the English Channel. And they have these beautiful white cliff face. That's all calcium carbonate, which is just chalk. And it does not dissolve nicely in water. It does dissolve a little bit, which is why limestone eventually like gets washed away by water, but it doesn't dissolve wet. So it will be a solid.
Oops. Oh, no. I was writing the word, instead of writing the formula carbonate, I wrote the word carbonate.
That's
That's really great. We just retry that again.
But you know, which school we call your teacher mom.
Oh my god.
Oh.
That only
That's a
one
cute
was- it's so funny.
So embarrassing.
I did that a lot in elementary school because I would have off days.
Miss B on purpose though.
You, Miss Farmer.
People have done that to Miss Farmer on purpose too.
Is that your
I don't care how many times you call me mom, I'm not gonna respond.
You're kind of a man.
He's a manly mom.
I am manly. That's one of the first things people notice about me.
And then
You're like a
Manly
squishy teddy bear. You are. You're a giant teddy bear for a teacher.
Please be a giant teddy bear for next hour.
When I was at South Lincoln High
yes.
School, we always made new teachers wear the bear mascot costume. So we always told them it was like a big tradition. And at the first like sporting event of the year, the newest teacher always has to wear the bear costume. It was funny every time.
What if there was no new teacher?
Well, you couldn't do it. You know, I don't think I've ever taught a school year where there isn't a new teacher at a school. Like, have you ever had a year where there isn't somebody new?
Does that mean that you're always expecting somebody to get fired or moved away?
Well, yeah, it just happens. Retirements, people move.
Half of the staff at PE all disappeared between 1 year.
Yeah, people move, right? Like, it's reality. I've taught in, I mean, not counting supply work. My first semester as like, my first day as a supply teacher was at Grimsby, but then I supplied at almost every school on the board. But I have actually like been a classroom teacher at Grimsby, then at South Lincoln, then back at Grimsby, back at South Lincoln, then at Fort Erie, then back at South Lincoln, then at Sir Winston, then back at South Lincoln.
How many times have you been at South Lincoln?
I taught there for 6 years total.
Did you supply here before you got here?
Please tell me.
I did never supply here. I never did a supply work here.
Mr. Lando, which school was it that the new teacher had to always wear the bear
South
costume?
Lincoln. They were the Bears.
So how many times did you have to put that on?
I never did.
That must have been unbearable.
I haven't done it, yeah. But I will. And we will get them there so you can come and paste.
You're welcome.
Should I just hang around?
You're welcome for my pun.
Let's do this.
Let's do this.
It was a stupid, easy pun. You made it so easy. It was so unbearable.
Landra, what's unbearable is the fact that you make puns about bears all the time.
But it's so easy.
Whoa! To record that.
Did you see that Sylvia and Co. in their first year at Grimsby won a championship?
I can't bear to sit there and not make a pun.
His first year at Grimsby, and the first time he's had a football team in like 7, and they won the championship.
You're just done with me.
But that's in a small
I can feel it. I'm done with you. Go away.
She's a great and foods teacher and parenting teacher. Sylvie's such a bag. I love that guy. He's so contradictory.
I think you also just trying not to talk so you don't have to listen to yourself and you have to listen to the lesson.
Oh, that's cute.
Hello,
guys,
Kira, that
I
will be
want
watching
to get in
this.
the habit. I don't know why they haven't always been like this, but when you return a calculator, can you return it to its appropriate
Hug
numeric
cuddles for
slot?
me. Good, I definitely know.
Things not having numbers in places makes me feel crazy.
Mr. Orlando, just to let you know, I still have the calculator I borrowed.
Okay. I gotta steal this back.
Yeah.
What I should be able to do, no promises here. What I should be able to do,
Work or it's not.
yeah, I should be able to put into OneNote, which does